Hello and welcome back to Calero Academy. If you remember our last video, we were supposed to find the plane that contains two vectors. Vector 1, which will equal 0, 1, and 2 minus 2, plus t times 2, 3, and minus 1, and vector 2, which will equal 2 minus 1 and 0, plus the same t times 2, 3, and minus 1. Sorry about that. So anyway, we promised 3 approaches in 3 parts. This will be the second part, and we'll be using the 3 points approach. Approach B. In approach A, we use the cross product to find the answer. Now, we're going to use 3 points. Here's how we do it. Approach B. Okay. They give us 2 points already. 0, 1, and minus 2, comma. And 2, minus 1, and 0. So, where can we find a third point? The way you can create another third point at random is, look at vector 1. It defines a line, and as you plug in values of t, you get new points in that line. So let's take t is equal to 1, and point 3 will be a point on v1 at t is equal to 1. So point 3 is equal to 0, 1, and minus 2, plus 1 times 2, 3, and minus 1, which will equal 2, 4, and minus 3. Okay. Now, we saw that in the last video you could write the equation of a plane as a of a times x minus some value of x plus b times some value of y minus some value of y plus c outside of z minus some value of z all equals 0. But there's also another way to write it. You can just write it as ax plus by, sorry about that, by plus cz plus d is equal to 0, where d is going to be equal to all that stuff that's being left out over here. Like the d will be equal to minus ax0 minus by0 minus cz0. So, now, what we're going to do now is that we're going to create a 3 equation simultaneous equation. Then we're going to use some cool tricks in a mathematical toolbox to solve it. So, first, let's create our 3 system equation, 3 systems simultaneous equation. We can create 3 equations, 1, 2, and 3, by just plugging the points that we know into our equation over here. That way we'll be able to get A, B, C, and D, hopefully. So anyway, we have point 1, 0, 1, minus 2. Plug that into here, and we'll have B minus 2C plus D is equal to 0. Second point is 2, minus 1, and 0. This will give us, plugging in, 2A minus B plus D is equal to 0. And lastly, using our new point, point 3, 2, 4, minus 3, this will give us 2A minus plus 4B minus 3C plus D will equal to 0. Now, as you might have noticed, this is an equation of 4 unknowns and 3 equations, which would be impossible. However, what we're going to do now is that we're just going to try to find all the other terms. We're going to try to solve all the variables in terms of C. Then I'm going to show you this very cool trick. So, let's just do some algebra here. Let's add equation 1 and equation 2. This will give us that 2a minus 2c plus 2d is equal to 0, which will lead to a being equal to c minus d. Now, 2 minus 3, the equations, equation 2 minus equation 3, will give us minus 5b plus 3c is equal to 0, which will lead to b being equal to 3c on 5. This is our equation 5. This will be equation 4. Note, we've already got one variable down in terms of c. So, now let's do equation 3 minus equation 4. Minus equation 1, And look at it. It would be simpler for us if we do it 4 times the equation 1. So we just multiply everything in equation 1 by 4 and subtract it from equation 3. That'll get rid of that b for us. So this will give us that 2a minus 3c plus 8c minus 3d is equal to 0. This will give us that 2a plus 5c minus 3d is equal to 0, or that a is equal to 3d minus 5c over 2. Now we need to find the representation of d, because then we kill 2 birds with 1 stone. We get d down in terms of c, and then we can substitute into a, and we'll have a in terms of c entirely. So now let's equate equations 4 and 5, and 6, Let's have this be equation 6. Equation 4 equals equation 6. Sorry about that messiness there. This will lead to c minus d is equal to 3d minus 5c on 2. All we did is that we took equation 4, a is equal to c minus d, and set it equal to 3d minus 5c on 2. Now, after some little algebra, we'll get that d is equal to 7c on 5. Okay, now let's plug back into equation 6. That will give us that, a is equal to minus 2c on 5. 7c, 3 times 7c on 5, that's 35 on 5. That's 35 on 5 is equal to 7, and then you have it done. So, now, what we do now is that now that we have all of our things in terms of c, let's write them out. A is equal to minus 2c on 5, b is equal to 3c on 5, and d is equal to 7c on 5. Let's think for a moment. What can we do to fulfill our equation and get our equation? Now, let's take a little quick reminder course. Suppose we have x, y, and z, that when we put into our equation a, x plus by plus cz plus c is all equal to 0. So we have a point x1, y1, and z1 that fits that equation. However, this will also fit in the equation constant, or lambda ax plus lambda bx, lambda by plus lambda cz plus lambda d is all equal to 0. All we're doing is saying that if we multiply the entire equation by a constant, x, y, x1, z1, and z1 will still work in that equation. Now, however, that means that that a, b, c, and d are not unique. They're not the unique coefficients of the equation over here. You could have as easily lambda a and lambda b and blah blah blah. Now, now let's try to, okay, if it is true that we could take some x to make any one of the coefficients be whatever we like, we could take some lambda, so not x. We could take lambda to be any number we want, and we could turn any one of these variables into any number we want. So, suppose that we want lambda is equal to 5 on c. Since that the coefficients are not unique, we can create a new set of coefficients that will work for this equation, lambda a, which will equal to 5 on c times minus 2c on 5, which is equal to minus 2. Doing similar things on the other guys, lambda b will equal 3, lambda b, and lambda d will equal 7. Now that we have all of that done, and also note, what is going to be lambda c? Lambda c will simply be equal to 5c on c, which will equal to 5. So now, that means we basically got the answer, but now let's take a little bit of a moment to understand what we've just done. All we're saying is that if we know that a, b, and d work in our equation, we can multiply the entire equation by lambda, a constant, and then the coefficients a, b, c, and d will not be unique, and we can create new coefficients, lambda a, lambda b, lambda c, and lambda d, to work in there. And since we can pick any lambda we want, any constant, we can pick it here to be to our advantage. We can pick it to be 5 on c. And it turns out that's perfect for us here, because it solves everything very nice and well. So now let's just plug into our equation, so we have lambda a x plus lambda b y plus lambda c z plus lambda d is equal to 0. Plugging in, we have that minus 2x plus 3y plus 5z plus 7 is equal to 0, which is the correct answer and which we got in approach A. So, thank you for watching, and this has been a Calero Academy production. If you have a question for us, or if you want us to make a video for you of a certain question, Calero Academy will now start taking comments, suggestions in its comments section, and if we like the suggestion, we'll make a video of it. So thank you for watching again, and hope you come back.